In this example, I'm asked to analyze each of the data sets to determine if the set can best be modeled by a linear or exponential function, and then write the equation that goes along with the data set. So let's take a look at the first data set. The first thing I notice is that all of my inputs are separated by 1. So all of my delta x's are 1. So I'm going to fill out that part of the table. And what you might want to do here is to stop the video momentarily and go ahead and write these tables down, because they're not included in your workbook, but they will help you to analyze the data sets appropriately. The next thing I'm going to look at is the change in y for each one. So I'm going to look at the change in y between 1/5 and 1/25, 1 to 1/5, 5 to 1, 25 to 5, and I see that there is no pattern in the change in y. These are not equal, so I'm not even going to waste my time and compute those values. I'm just going to look at this and say not linear, because the rates of change are not equal. So what I'm going to do is hope that the data are exponential, and in order to determine that, I am going to look at the ratio of y2 to y1 for each of the values here. So 1/5 divided by 1/25, I'm going to write that here. That's 1/5 times 25 over 1. That gives me 5. Here, 1 divided by 1/5 is the same as 1 times 5. That gives me 5. So I see a pattern starting to emerge. 5 divided by 1 is 5. 25 over 5 is 5. 125 over 25 is 5. 625 over 125 is 5. So that means that my data are exponential, and my b value is 5. My a value is my initial value. It's when the input is 0, the output is 1, so I can use the generic exponential equation, y equals ab to the x, and fill in the pieces here. A is 1, so I don't need to write that. I can just write the b value to the x, and there is my exponential equation. So I'll go ahead and write exponential here. Notice that what I didn't say here is that these data are exponential because they're not linear. This is not an either or. It could be the case that it's neither one. So let's take a look at this next one. Again, I'm looking at the inputs. They're all separated by 1, so I'm going to indicate that my delta x is 1. If I look at my delta y, I see that there's a difference of 0.2 in each one. 0.2, 0.2, so I'm subtracting. This one minus this one gives me 0.2, 0.2, 0.2, 0.2. So my delta y for all of these is 0.2. So I'm going to write that in my table, and just so you can see one of the computations, the first one, -3 minus -3.2 is -3 plus 3.2, which gives me my 0.2. The ratio of all of these is 0.2. So therefore, I have a linear model that will work the best for these data. So to find the equation, I need the information for y equals mx plus b. Well, the value that I found here, delta y over delta x, that's my slope. So I can fill that in. So y equals 0.2x, and then my b value is my starting value. When the input is 0, the output is -3.2. So here is my linear equation that best models the given data set.